In this episode, we're going to look at how to use link layer discovery protocol to map a network. I'll show you how to do it, and we'll talk about the ideas along the way. A senior network administrator requires us to map a remote branch office network and discover information about all the devices in the network. We must record all the network device names, IP addresses, subnet masks, and physical interfaces that interconnect the network devices. To map the network, we will use SSH for remote access and the Link Layer Discovery Protocol, LLDP, to discover information about neighboring devices. Because LLDP is a layer 2 protocol, it can be used to discover information about devices that do not have a layer 3 connectivity. We will record the information that we gather to complete the addressing table and provide a topology diagram of the remote branch office. We'll be discussing how to map a network using LLDP and SSH for remote access. Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Packet Tracer Lab 10.2.6. Use LLDP to map a network. The Packet Tracer Lab opened up here. On the left side, I have a work area, I have a topology. This is where we're going to connect with our devices. On the right side, I have our instructions. On the bottom right, I have the Packet Tracer activity window that opens up with Packet Tracer. In the upper right, the majority of the right side, I have a Word document of those same instructions. The reason I have the Word document is we have to fill in this addressing table. There's questions to answer. Word document will allow me to save my answers when I'm done. Here's our network. We're going to be working from the admin PC. You're going to be sitting in your office and you'll be able to remotely do what you need to do from your office. This up to the edge router is the headquarters. This is where your office is located. Then the edge router is connected to the internet. And then we have the branch office. This branch office is where we're going to be doing our work. Now, all you know about the branch office right now is some information that is going to be given to us in the lab, but it's a cloud, and we need to figure out what's happening inside the branch office, yet while we're staying at our admin computer in headquarters. Here we have our addressing table. We know some of the information in here, but it's a lot of empty table, so we're going to be filling in quite a lot of this. I'm going to scroll down here. Objectives, we're going to be using LLDP, Link Layer Discovery Protocol, and SSH for remote access. What you have to do is map the remote branch office network. You have to map what's inside of this cloud over here and discover information about all the devices in that network. We got to record all the device names, IP addresses, subnet mask, and physical interfaces interconnecting those network devices. Now, to map this network, we're going to use SSH for remote access. We're going to go from our admin PC, and then we're going to SSH into the switch or SSH into the router. Once we're connected to there, then we're going to SSH into another device, and then another device. LLDP is used to discover information about neighboring devices. Because LLDP is layer 2, it can be used to discover information about devices that don't have layer 3 connectivity, that do not have layer 3 addresses, do not have layer 3 IP addresses. So we can connect to them even though they don't have IP addresses. We're going to record information that you gather in the addressing table above. We're going to draw out a topology also. We're going to need the IP addresses for the remote branch office, which is here, and then the local usernames and passwords. Here's our local username and passwords. Because we are looking at creating this topology diagram of the network office, I'm going to use a pad of paper. Right next to me, I have a pad of paper. I got a pen. And I'm going to be drawing the network as we use LLDP, Link Layer Discovery Protocol, to figure out our devices and the connections and what devices are actually there. The other thing I did is we have our passwords. We have the local network, our passwords. We'll use that to connect into any of these devices. That's our local network in headquarters. And then we have the remote branch office network that will use those credentials to log into any device here in the branch office. Now, to the astute eye, yes, the passwords are the same. That makes it a little bit simpler. What I've done for the ease of the lab is I have another sheet of paper where I wrote down the usernames and passwords. That way I don't have to keep scrolling back to them all the time. One other thing I'm going to do is a function of Microsoft Word here. Underneath the View tab, there is the split screen. The split screen allows me to split my screen and have basically two independent scrolling sections. So I can scroll the top differently than the bottom. If I scroll up, you can see that it's both the same things, but now I can scroll up to the addressing table. It'll allow me to see information, to type in information while still looking at my instructions. So using the split screen here is going to help me with this lab. We are ready to get started. Part 1, use SSH to remotely access network devices. In part 1, we're going to use the admin PC. That's where we're at right now. That's you sitting in your office to access the Edge Gateway router. Next, from the Edge Gateway router, we'll SSH into the remote RBO office. So we're going to SSH into the Edge. Once we're connected there, then we're going to SSH into the remote branch office. On the admin PC, open up the command prompt. Right here is our admin PC. I'm going to slide it over. I'm going to make the window a little bit bigger, going right to left. On the desktop tab, I'm going to go ahead and click on our command prompt app. It's going to open up our command prompt. Part 1B, SSH into the gateway router at 192.168.1.1 using the username of admin0 and the password. Now to use SSH, we go ahead and type in SSH space and then -L. That's a lowercase l. What that means is the next thing I'm going to specify, log in as that username. The username we're using is admin01. And then we have to specify the IP address. That IP address is 192.168.1.1. 192.168.1.1. Asking us for a password. Here is our password. Capital S3CRE, capital P, @55. If you do it wrong, it'll let you know. I need to retype it. Capital SCRE 7. I forgot the 7 the first time. Capital P @55. S 3 CRE 7 capital P capital A 55. And once you're successfully in, we will see the name of the device and we are at privilege exec mode. How do we know privilege exec mode? We have the pound sign, the hashtag, the octothorpe, or the waffle sign. Whatever you want to call it. Looks like a small tic-tac-toe board. Notice you're placed directly into privilege exec mode. This is because the admin01 user account is set to privilege level 15. On Edge user, we created a user called admin01 and we gave it privilege level 15. Automatically takes us into privilege exec mode when we log in as that user. On the C, the Edge router was previously configured using CDP. Once again, we're going to use LDP. Switch S1 has already been configured to use LLDP. Issue the show CDP command to verify CDP is currently active. Disable CDP by issuing the following command. Okay, first thing we're going to do is verify that CDP is active. That is show CDP. Hit enter. Here we have global CDP information and we are sending CDP information. So CDP is active. CDP, Cisco Discovery Protocol, is proprietary. LLDP is a multi-vendor discovery protocol. Now we need to disable that. We have to be into global configuration mode. So go ahead and type in config T. To disable it, we have to type in no CDP run. That turns off CDP. Go ahead and type exit, and we can do the show CDP command again. And now it's telling us CDP is not enabled. That takes care of C. On to D. LLDP can be configured to both transmit and receive on a specific interface. Configure edge so that it will receive LLDP messages from S1 but does not send messages to S1 for security purposes. Enable LLDP. Well, first thing we have to do is enable LLDP. To enable LLDP, it's LLDP and then run. Just a simple little command, LLDP, run. Cisco was kind enough to let me know I did something wrong. It's saying I have invalid input detected at the up sign, so the up sign here, and I did spell LLDP space run correctly, but this is not a privileged exec command. You have to do that in global configuration mode. Enter in config T, takes us into global configuration mode. Now I can do LLDP run. And LLDP is running. If you type in exit quickly and do a show LLDP, it is active. LLDP is active. Okay, once we have it active, we need to does not send messages to S1 for security purposes. So we're going to stop the transmitting of messages to S1. To do that, we have to go into that interface. So we have to go into global configuration mode first. So config T, and then our interface. So interface of G0/0. And now we can tell it LLDP, don't transmit out of this interface. The command here is no space LLDP transmit. That'll stop any LLDP packets from going out of our gig 00 interface to switch 1. Exit takes us back to privilege exec mode. On to E. Use the show LLDP neighbors command to verify that edge is receiving messages from S1. So we're on edge, and we're going to use the show LLDP neighbors command to verify we are getting messages. We are getting messages here in LLDP. We show that we are connected to S1, and that's what we're looking at. On to step F. Connect to S1 with SSH from the edge router using the admin 01 credentials. Issue the show LLDP neighbors command. Notice that S1 did not receive information from the edge. Command is SSH space -L. We're using the admin 01 user, and then the IP address of 192.168.1.2. It's going to ask us for our password, capital S3CRE7, capital P @55. We are now connected into S1 at the user exec level. Use the show LLDP neighbors command to verify we did not get any information. So show LLDP neighbors, and we have no devices listed. There would be a device listed right in here, right in this area, if it got any transmits, but because we didn't get any transmits, we know nothing about our neighbors because the neighbor was not transmitting anything to us. Okay, we can go ahead and type exit. And exit ended that SSH session from when we SSH'd into S1. Exit out, we are now back in the edge router. Exit from the connections with S1 and return to the edge router. Use the show IP interfaces brief and show interfaces command to document the edge router's physical interfaces, IP addresses, subnet mask in the addressing table. Up here in the addressing table, here's edge 1. We have some empty fields. We need to document the IP address and subnet mask. First command we're going to use is the show IP interface brief. Here it says we are using 2 ports. First port we're using is the gig 00 with an IP address of 192.168.1.1. And then the second port we are using is serial 000 with an IP address of 209.165.200.5. If I was to make an educated guess, I would say the gig 00 address with the 192.168.1.1 is this interface right here. And the reason I say it's this interface is it's a private IP address. Private IP addresses are not routable on the internet, but we can use them on our internal network. So that is probably gig 00 is this interface here. Then the serial 000 interface with 209.165.200.5, that's a publicly routable address across the internet. That is probably the internet facing side of our edge router. That serial 00 is over here on this side. Okay, information we need here. We need the IP address for serial 00. That's the 209.165.200.5. So 209.165.200.5. And we need the subnet mask. We can't get it from here, but if we use that second command, show interfaces, that'll give us our subnet mask. Go ahead and enter in show interfaces, and we are looking for the serial 000 interface. This is gig 00. That's not what we're looking for. We have the more at the bottom, so I'm going to hit space bar once. This is gig 001, still not the serial 000 interface we're looking for. Hit the space bar a second time. Here is serial 000. It's up. It has an IP address of 209.165.200.5. That's what we have in our table right there. And then it has a /30 address. /30, 31s followed by 2 zeros. And our subnet mask, convert that into dotted decimal notation. That is 255.255.255.252. Okay. Hit spacebar a couple more times, takes us through all of our interfaces. On to H. From your session with the edge router, connect to SSH to the remote RBO office at 209.165.200.10 with the username RBO admin and the same password. Okay, so they're giving us the IP address we're going to connect into here. The command for that is SSH space -L for login with the username of capital R, capital B, capital O, admin. And then our IP address of the device we're connecting into, 209.165.200.10. Asking us for our password, capital S3 CRE 7 capital P @55. We are now logged into the RBO Edge router. The RBO Edge router. Question: after connecting to the RBO office at 209.165.200.10, what piece of previously information can now be added to the addressing table? Up here, well, we connected into 209.165.200.10. This is the row we're looking at. That's that IP address. Well, we have the gig 00, but we don't have our device name. Without doing anything else in this window, we can at least tell you that this device host name is RBO-Edge. We can go ahead and type that in our table. So RBO-Edge. And to answer the question, host name of capital R, capital B, capital O, dash, capital E, D, G, E. Takes care of H. So we are now connected into our router. Let's look at our diagram. We are sitting in your office, feet up on your desk, listening to your headphones in air conditioning, in your comfy chair. You have now connected into the edge router and then connected into the branch office edge. So you are just at the beginning of figuring this out. Now, where is the branch office? It could be anywhere. It could be in the same building. It could be across the street, across the town, the other side the continent, the other side the world. The internet, as long as it's connected to the internet with a routable IP address, you can sit in your office and do whatever you need to do anywhere this remote branch office is in the world, as long as it has the IP address that's routable across the internet. Part 2, use LLDP to discover neighboring devices. We are now remotely connected to RBO Edge router. Use LLDP, begin looking for connected network devices. Issue the show IP interface brief and the show interfaces commands to document the edge router's interfaces, IP addresses, and subnet mask. Add the missing information to the address table. Okay. So the first command is show IP interface brief. That will give us a nice little table of information. And it's going to show us that we have 2 active connections. First one here is gig 000. Once again, how I know it's active, it says status up, protocol is up. So gig 00 is one of our active connections. And the second active connection is gig 01. That is all missing information in our table. Let's go ahead and add that in. First thing is the device name we are on. We are on RBO Edge. So we can go ahead and type that in here. RBO Edge. We already have an entry up here for one of them. We're going to add in a second one because we have 2 connections. You can see here we have gig 01 on RBO Edge. That takes care of this entry. And then we have gig 01, the second entry. So we have gig 01 already in our gig 00 already in our table. And we have gig 01 is the new one. Let's go ahead and enter in G0/1. Then we can get our IP addresses. Gig 00's IP address 209.165.200.10. We already have that in our addressing table. Gig 01, 192.168.3.249. 192.168.3.249. We can't get our subnet masks from here. That will be in our second command, the show interfaces command. Go ahead and enter that in, show interface. It'll give us detailed information about each interface. Here is gig 00, saying that we're up. Here's our hardware address, our MAC address for gig 00. Here's the internet address, 209.165.200.10. That's what we have in our addressing table. But then at the end of this line, right here, at the end of it, is a /30. That's our subnet mask. Taking a /30 into dotted decimal notation, that is 255.255.255.252. That is our subnet mask. And now let's go ahead and get the subnet mask for gig 01. Back in our window here, you can see that there's more information to display, represented by this -- more -- What I'm going to do is you could hit enter. It'll take you down line by line, or you can hit the space bar and it'll scroll a whole page of information. I'm going to hit the space bar once. Here's gig 01. That's what we're looking for. Here's its IP address, which we have in our table. And then we also have the subnet mask, which is a /30, which is our 255.255.255.252 subnet mask again when we write it out in dotted decimal notation. as we write this information out, I am going to start drawing my chart. Right now, my chart has nothing in it. It's just a blank piece of paper. And first device I'm going to connect into or draw on here is RBO edge. So I'm going to draw a circle representing a router, because if you look at the symbols, the router sort of looks like a circle. For those of us with no artistic ability, I just draw a circle and then some arrows going through it to represent the router. I'm going to write the name next to it, RBO edge. And then that had two connections coming in. One from the top, one from the bottom. So my drawing looks like this right now. The connection coming in from the top, that's coming from the internet. That's how we're coming in. So I'm going to write ISP there. And that came in on the gig 00 interface. So I'm going to write G0/0. Then I'm going to put the IP address next to it, which was 209.165.200.10. And then the other interface going out the bottom was gig 01. So I'm going to write that by the interface. So gig 0/1. And then that IP address was 192.168.3.249. This is what my drawing looks like right now. Not fancy. It's probably might be difficult for you to read, but I can understand it. I now understand how that is connected to the network. I now know part of what's happening inside of this cloud. I now know part of what's happening in there. Okay, so I updated my drawing. That should take care of part 2, step A. On to B. Security best practice recommends only running LLDP when needed. So LLDP may be turned on. Use the show LLDP command to test this. Okay, we're still in the middle of this show interfaces command over here. It says that we have more information to display. I can spacebar a bunch through that, or I can just hit Control C and it'll end it right there. Command we're entering is show LLDP. I hit enter and it's telling me LLDP is not enabled. You need to turn on LLDP, but it's a good idea only to send LLDP information to internal network devices and not external networks. What we're saying here is we want to send LLDP information to our internal network, but not broadcast it on the internet. To discover which interface is connected to the internet by using the show IP interfaces brief command. Once again, we are on the RBO edge. I'm going to go ahead and enter in the show IP interface brief command. Now, to discover that, that's what we talked about early. We have to look at the IP addresses. The address that starts with 192.168, that is a private address, not routable across the internet. This will be going to our internal network. 209.165.200.10, that is a routable across the address. That is a public address. That will be the interface that we don't want to send LLDP information out of. That is the gig 00 interface. Gig 00, we do not want to send information out of. Enable LLDP protocol and completely disable LLDP on the interface that is connected to. Once again, LLDP, there's a transmit portion and then there's a receive portion. So you have to stop both of those from happening on our gig 00 interface. Okay, let's go ahead and do that. First, we need to enable LLDP. We do that from global configuration mode. So go ahead and type in config T. Now, to turn on LLDP, all you have to the command here is LLDP run. That turns on LLDP. If we exit out quick and do a show LLDP, we can see that LLDP is active. Last time we ran it, LLDP was not enabled. Now it is. We can now start start stopping LLDP information from going out our gig 00 port. To do that, you have to go into the interface. First step, global configuration mode, config T. Then we need to go into that interface. So interface G0/0, 0/0 right here. That's our internet facing port. Go into that interface of G00. Now we can stop LLDP from transmitting and receiving. To do that, we type in no space LLDP and then transmit. That stops it from transmitting. We also need to stop it from receiving in on there. Command here, once again, is no space LLDP and then receive. That stops it from receiving in on that port. You can go ahead and type exit. Exit takes us back to privilege exec mode. Issue a show LLDP neighbors command to find the neighboring network device. LLDP will only show connected devices that are also running LLDP. You need to turn LLDP on your devices if you want them to discover each other. Let's go ahead and enter in show LLDP neighbors. When we run it, we get one device back. There is one device running LLDP directly connected to us. That is the RBO-firewall, the remote branch office firewall that is connected directly to us. Is there a neighboring network device? What type of device? What's its name? On what interface is connected? Is the IP address listed? Then record the information in our addressing table. Okay, let's go ahead and answer these questions. First question is there a neighboring device? Yes, there is. What type of device is it? Over here, looking at our show LLDP neighbor command, underneath capability. Underneath capability says an R. If we go up to our capability codes right here, R is a router. So it is a router. What is its name? The device name is the device ID. It's RBO firewall. Capital R, capital B, capital O, dash, capital F, IREWALL. RBO firewall. On what interface is it connected? Well, it's connected into two interfaces, really. It's connected on our local device on the RBO edge, and that would be our local interface. And then on the far device, the actual RBO firewall, because once again, you got a cable, you got to plug it in two places. One gets connected into the device we're in, RBO firewall, and then the remote device, we're connected into RBO edge. That's our local one. And then RBO firewall, that's the remote device we discovered. That also has to get connected into the port. And so there are two connections. For RBO-edge, it's connected into our local interface of gig 01. So gig 01. And then on the far device, RBO firewall, RBO-firewall, I spell firewall correctly. It's connected into, underneath port ID, it's connected into gig 00. That's on the far side. Is the device IP address listed? Looking here, when we ran the show LLDP neighbors, I am not seeing any IP addresses for our devices. So no IP address. No IP address. Record the information in the addressing table above. Well, once again, we are on the RBO edge. So actually we have two entries already for the RBO edge. We are on the local interface here on RBO edge of gig 01. So we'll be looking at this line of information. We don't have anything about IP addresses. We got that earlier, that information. But what we can tell you is The interface we're connected into on the far side, so that's the port ID on the far side on RBO firewall, we're connected into gig 00. You can say gig 0/0. And then what is the name of the device? And that is our RBO firewall. RBO-firewall. Once again, I got to spell firewall correctly. Takes care of step D. On to step E. Use the show IP route command to determine the address of the device you found with the show LLDP neighbors command. Well, we found RBO firewall. Now we have to use the show IP route command to figure out what that IP address is. Based on the information provided about the local addresses in the routing table and the prefix length of the network, use that information to determine the neighbor's address. Okay, first off, let's start with looking at the show IP route command. Show IP route. This is our routing table. We have our codes here. We have our gateway of last resort. And then we have our information. Using the information from our LLDP neighbors, and we can use our addressing table here. This is the information we found using our LLDP neighbors command. Determine the IP address of our next device. Well, RBO is internal, so that would have a private IP address. Over here at our routing information, that would be our 192.168. 209 is external, that's outside of our network, so that's not part of our answer, but this 192.168, that's part of our network. Looking at that, the network that's directly connected to us is 192.168.3.248. That's the network address. Convert that to binary, ends in zeros, especially when you use the subnet mask of /30. /30 only gives you 4 IP addresses. And of course, the rules of IP addresses are, can't use the first IP address, right? It gives us 4. You can't use the first one. That's the network address. You can't use the last one. That's the broadcast address. That gives us 2 addresses that are usable left. We have 2 addresses that are usable. Then we look at the local address. That is the IP address here of our gigabit Ethernet 01. They are using .249. So 248 is our network address, right? 249 is the gigabit Ethernet address. Then we have another address, and then the fourth one's our broadcast. So this third one here is the one we're using. 248 is the network address. 249 is gig 01. 250 is that IP address of the RBO firewall. .250 is the IP address of the RBO firewall. So we were able to use the show IP route command with the information we got earlier to figure out what the IP address does, or what the IP address is. So we are connecting into the .250. To find additional information from the neighboring device, use the show LLDP neighbors detail command. Now, before I go ahead and do that, what I'm going to do is I'm going to update my drawing before I forget what that address is. Currently, I have the internet to RBO edge. Now we know RBO firewall is our next device. So I'm going to draw a circle representing the RBO firewall. Once again, that was a router. I'm going to put its name down, RBO-firewall. I don't know. Actually, I do. I know what port it's coming in on the RBO firewall, so I can write that on my diagram. So that's coming in on G0/0. And then I just figured out what the IP address was. That was the one that ends in .250. And so that IP address is 192.168.3.250. Here's what my chart now looks like. Okay, back to running the show LLDP neighbors detail. Let's
go ahead and run that command and see what information we get. Show LLDP neighbors detail. We are getting the chassis ID, which happens to be the MAC address. We are getting what that port is we are connected to on that far device. So we're connecting into gig 00. Then we're getting the name of that system. That's RBO firewall. We get some other information. The question here is, what other piece of potentially sensitive information is listed? Well, we got MAC address, not too critical. We've got what interface we're connected to, gig 00. That doesn't seem sensitive. We got the name of the device. That could be a little sensitive, but I don't know, probably not. Next one here is underneath system description. We have the version of software. Now, this could be critical. Why could it be critical? Because if they're using an outdated version of software, there could be a vulnerability, and a threat actor could use that to attack that device, get access to it somehow. And so the potentially sensitive information here is the neighboring devices iOS software version. Okay, then we have a little note here about packet tracer does not provide management address of the neighbor device. We don't get the address for RBO firewall. We don't get that management address. That's why we had to go through the mental exercise of using the show IP route statement. In this activity, several of the neighboring addresses will be provided for us. Well, that was nice of them. Connect to the neighbor device with SSH to discover the other devices. We're going to go from the RBO edge to the RBO firewall with that address we have. Once again, I documented it on my network diagram, so I have that. We're using SSH, so we start off with SSH space -L using the user here of capital R, capital B, capital O, admin, and then the IP address that we figured out, 192.168.3.250. Asking for our password, capital S, 3CRE7, capital P, @55. And we are now logged into the RBO firewall. After successfully connecting with SSH, what does the command prompt show you? Well, the command prompt shows us the name of the device, which is RBO-firewall, followed by the hashtag, the #, the octothorpe, or my personal favorite, the waffle sign. Shows the name of the device and then what mode we're in. We are in privilege exec mode. On to H. You are remotely connected to the next neighbor. Use show LLDP neighbors and show LLDP neighbors detail command to discover other connected devices. What types of network devices? So what type of devices are neighboring this? Record newly discovered in the addressing table, including host name, interfaces, and IP addresses. So first command we are entering is show LLDP neighbors. Here on show LLDP neighbors, RBO firewall has two neighbors, RBO edge, that's where we just came from, and then we have switch RBO1. That's a new device to us. But because we have two connections here, we're going to put two entries into our addressing table. We have two entries there. We are going to put those both into our addressing table. Let's go ahead and start filling out some information we know. What is the device name we are on? We are on RBO firewall. We can go ahead and enter that one in, RBO-firewall. I can do that in the second row because We have two interfaces to enter in. So RBO firewall. Then let's work on the first one. Looking here, we have one that's on gig 00 and one that's on gig 01. Let's go ahead and do the gig 00 first. This is the local interface, local to the device we're on. So we're on firewall 1, and the local interface is gig 00, and that is connected to RBO edge. So the local interface is gig 00. That's the next column we need to fill in. So gig 00. We don't know IP addresses, but we do know that we are connected on the far end to gig 01. So we can enter that in here. So gig 0/1. And the name of that far device is RBO edge. RBO-edge. That's just where we came from. But now we have our new device down here. Our new device, our local interface here is gig 01. So on RBO firewall, it's connected into gig 01. Gig 0/1. We don't know our IP addresses yet, but we do know on the far side we are connected into gig 01 also. So G 0/1. And the name of that device on the far side is SW-RBO1. And we can fill that in. SW-RBO1. Switch remote branch office 1. Yeah, that's all we can get from the show LLDP neighbor command. Let's go ahead and enter in that second one. And that was show LLDP neighbors detail. We have some information. You're going to have to scroll up to see all of it. Once again, this is why I hit enter a couple times before I enter in a command, so I can easily scroll up to see, okay, when did I last enter in my command? Right here, jumps right out at me. First one we're showing here is a MAC address connected to gig 001, and that would be our RBO edge. We have that information. We are connected into that device. Here's the second device. IP address, that the interface we're connected into, and the name of that device. Missing piece of information yet is our IP addresses. To get that, we can't get that from LLDP show neighbors detail. CDP neighbors detail, that shows it, but LLDP show neighbors detail does not do that. What we have to do is figure out that information. We can use the show IP interface brief command. Gives us a nice table. Here's our gig 00 interface with its IP address, and the gig 01 interface with its IP address, but it doesn't give us our subnet. If we enter in the show interfaces, we have gig 00, we have our MAC addresses, then we have our internet address, our IP address, 192.168.3.250. Then that's a /24 on there. That's a class C address. We can enter that information into our table. 192.168.3.250, and the subnet mask is a /24, which is 255.255.255.0. We can go back to here and get the information for our gig 01. It says we have more information. You can hit enter, takes you down one line at a time, or I'm going to hit spacebar. Hit spacebar once. Here's our gig 01, our hardware address, and then our internet address. This is our IP address with a /25. We can go ahead and put that information in our table. 192.168.4.254. And that's subnet mask, a /25 converted into binary, dotted decimal notation. Take it into dotted decimal notation. That'll give us 255.255.255.128. We have all the information here. What I'm going to do is update my drawing at this point in time. I have my drawing here. I currently have RBO firewall as the last one, but I also now know that RBO is connected to switch 1. So I'm going to go ahead and draw switch 1 into here. Switches I'm going to draw as a square. I'm going to draw a line connecting to them. From RBO firewall, it's going out gig 01. This is gig 0/1. And I can draw that on my diagram by the RBO firewall. I can also put the IP address right there for it. 192.168.4.254. 192.168.4.254. And then I know it's connected to G01 on SWRBO1. So I drew that square for that next switch. I'm going to go ahead and write its name by it. So SWRBO1. And that is coming in on the G0/1 interface. We are still in the middle of a show command here. I'm just going to hit Control C to enter us out of it. Back to our question. What types of network devices neighbor this device? Well, we had a router here and an edge. Where did we get that information? Well, I'm going to go ahead, enter in show LLDP neighbor command again. And it gives us that information here. Okay. So what types of network devices neighbor this device? Well, we have a router, which was RBO-edge. How do I know it's a router? If I look at the LLDP neighbor command, here's RBO edge, and underneath capacity here, it says R. If we go up to capacity codes, R is a router. And then we have SW-RBO. If we go under capability, it has a branch, or has a B. B stands for bridge. So capability of B, it stands for bridge. In LLDP terms, that means it's a switch. Notice we don't have a switch anywhere in here. We do have an S that stands for station, but another way to think about a switch is a bridge. It's bridging devices together. For our answer, that says we have a switch, and that switch is called SW-BR-RB. Okay, let's start that name over again. That name is SW-RBO1. Then record any other information in our table. Last part of H here, add the newly discovered device name to the next SVI entry for address 192.164.4.131. What they're telling us is that next device, SW-RB1, has an SVI and it has an IP address of 192.168.4.131. We can go ahead and put that in our table. So our device name is SW-RBO1, and that's for our SVI, our management port, and that IP address is 192.168.4.131. That will allow us to connect into that next switch. Put an S there. LLDP does not give us that management IP address of the next hop. That LLDP does not function that way. If we were using CDP, Cisco's proprietary discovery protocol, it would give us that IP address. That's why the lab here is giving us this IP address. On to step I, connect to the SVI for 192.168.4.131 using SSH and the credentials. Let's go ahead and do that. Currently we are on RBO firewall. Let's connect into SW-RBO1. We're going to use SSH space -L. Then our username here is capital R, capital B, capital O, admin. And the IP address we are connecting into is 192.168.4.131. Asking us for our password, capital S3CRE7, capital P, @55, and we are logged into there. Before I do anything else, I'm going to write that SVI address on my network diagram here. So 192.168.4.131. Once again, documenting stuff as I go. Okay, so we are in there. We need to get into privilege exec mode. If we're asked for a password, we'll enter in our password. So enable, we are asking for a password, capital S3CRE7, capital P, @55. And now we are in privilege exec mode. Use the show LLDP neighbors command and the show LLDP neighbors detail command to discover other network devices. What types of network devices neighbor this device? Record any newly discovered devices in the addressing table, include host name, interfaces, and IP addresses. Okay, so what type of devices do we have connected to us? We need to enter in the show LLDP neighbors command. It says we have 2 devices. We are currently on switch RBO1. There are 2 devices connected to us, switch RBO2 and RBO firewall. We are going to go ahead and enter both of these into our addressing table. The device we are on is switch RBO1. We can enter that right here. So switch-RBO1. And we have 2 connections, so we're going to take up 2 lines. So S-RBO1. And then we can start entering in information we know. One is on gig 02, one is on gig 01. I'm just going to do them in numerical order. So I'm going to do the gig 01 interface first. So my local port here on switch SR or SWRBO1 is gig 01. You can go ahead and enter that here in the first field. So gig 01. We don't know the IP addresses of that yet, but we do know that on the far end we are connected into gig 01 also, so G0/1, and then that far device name is RBO firewall. We can enter that in here, RBO-firewall. That's all the information we can enter off for the first connection. Then we have the second connection. Local interface here on switch RBO1 is gig 02. So gig G0/2. We don't know IP addresses, but we can tell you that we are connected into gig 02 on the far end. So G0/2. And that interface or that device name is SW-RBO2. SW-RBO2. Question: what types of network devices neighbor this device? From the results of our show LLDP neighbors command, it's telling us that we have this device called RBO firewall, and it has a capability of R, which is a router. That gives us, we have a router, and that router is called RBO-firewall. The other device that was connected to us is called SW-RBO2. That has a capability of B. B stands for bridge, and LLDP to English translation, that means it's a switch. Another clue here is by the name SW for switch. So we have a switch and it's called SW-RBO2. So switch, and then that's called SW-RBO2. Also tells us to record IP addresses. Let's think about this. We are on switch RBO1. This is a switch here. Interfaces on a switch don't get IP addresses. So interfaces on a switch do not get IP addresses. That means we don't have IP addresses here. Last part of I, place a newly discovered device name next to the SVI entry for 192.168.4.133. What they're telling us, our newly discovered device, SWRBO2, has the SVI set up for the IP address of 192.168.4.132. We can go ahead and enter that in there. So our new device, SW-RBO2, has an SVI, and that IP address is 192.168.4.132. That takes care of step I. Onto step J. Connect to SVI address 192.168.4.133. That's another one. Using SSH and the credentials previously used. Issue the show LLDP command should receive the following message. Okay, so let's go ahead and SSH into that IP address. SSH space -L. Use the following name. Once again, our username is capital R, capital B, capital O, admin. And then the IP address we're being told to connect into is 192.168.4.133. Asking for our password, capital S, 3, CRE, 7, capital P, @55. And we are connected into RBO3. This IP address, 192.168.4.133, is for RBO3. Let's go ahead and put that in our addressing table. SW-RBO3 SVI, and that was 192.168.4.133. Next thing is we need to see if CDP is enabled. We use the show LLDP. Or so we need to see if LLDP is enabled. Show LLDP. LLDP is not enabled. Enable LLDP globally as in step C. Well, we need to get into privilege exec mode. Go ahead and type enable. Asking us for our password. Enter in our password. Capital S, 3, CRE, 7, capital P, @55. We are now into privilege exec mode. Turn on LLDP. We do that from global config. So type in config T. And now we type in LLDP run. Type out exit once. Do a show LLDP. And we are now active. No need to configure transmit or receive because they are on by default. Use show LLDP neighbors command in the show LLDP neighbors detail command to discover other connected devices. Okay, first command here is show LLDP neighbors. We have two neighbors. Once again, we are on SW-RBO3, and we have two neighbors, SW-RBO2 and SW-RBO1. Go ahead, create entries for these. We have these two in our table, so we're going to create two entries in our addressing table. We are on device SW-RBO3. So SW-RBO3, and the second line SW-RBO3. Two lines for two interfaces. Go ahead into sequential order, we'll do the fast Ethernet first. So our local interface, which is this column here, is fast Ethernet 0/24. We don't know what the IP addresses are, but we can tell you where we are connected. We look at our information. Once again, we are doing fast Ethernet 020, or 024. The remote port we're connected into is fast Ethernet 024. So we are connected into fast 024. And that device name here for fast Ethernet 024 is SW-RBO1. So SW-RBO1. The other connection, that local port on SW-RBO3 is gig 0/1. We don't know the IP addresses. Once again, they're switches, so they shouldn't have it, but we can tell you what is connected into on the other side. The other side of this local gig 01 connection is also gig 01, so G 0/1, and that is connected into device SW-RBO2. SW-RBO2. What type of networking devices neighbor this device? Well, looking here, we have this first one is a capability of B for a bridge. Translate that in from LLDP into English. That's a switch, and that's SW-RBO1. So we have a switch, and that was SW-RBO1. And then the other one is another capability of B, bridge. Translate that from LLDP into English. That gives us a switch, and that is SW-RBO2. So that is a switch, and that was SW-RBO2. Record any newly discovered addresses. We did that. Draw our topology. So right now, the last device I had written down here was SW-RBO1. From SW-RBO1, looking at our addressing table, we have the SVI here. So I'm going to go ahead, write that. I already have that written down on my table. And looking at our other informations, we have SW-RBO2 and SW-RBO3. So I'm going to draw a box on my diagram for SW-RBO2. I'm going to draw another box for SW-RBO3. From RBO1, RBO's gig 01 interface, we are connected into the firewall. I already have that one down. But then we have from SW-RBO1 here, the gig 02 interface is going to switch RBO2. Where I have switch 1 and switch 2, I'm going to draw a line connecting them. And so from the local gig 02 interface here, so gig 02 goes into switch RBO2, but the gig 02 interface there. I'm going to go ahead and write that down. We have an IP address here for the SVI on RBO2. I'm going to go ahead and note that 192.168.4.132. I'm also going to note the SVI for RBO3. 192.168.4.131. Note that one in there. We have these last two lines here. RBO3 has a connection from F024 to RBO1. So RBO3, so there's a line connecting RBO1 to RBO3. So from RBO3 F024, I can write that down, F0/24. That goes to F024 on RBO1. This is F0/24. And we also have another connection from SWRBO3 gig 01. We go to gig 01 on SWRBO2. So RBO2 and RBO3 are connected together. I'm going to draw a line connecting those. RBO3 goes from gig 01 to SWRBO2 gig 01. We have 3 routers that are all connected together. This is what my drawing looks like. Looking at my information, does not look overly pretty, but I am able to understand it. And I will be able to administer my network. If I want to, I could take it into the computer, draw it up electronically, maybe make it look a little bit more prettier. But I have now mapped out my network using LLDP. Step K, draw the topology, which I just did. Using the information we gathered with LLDP, what I'm going to do is I'll take a picture of this, insert it into my document, and allow me to save it. That was Packet Tracer Lab 10.2.6, Use LLDP to map a network. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.